The first problem asks you to find the pH of an HCl solution with the molarity of 0.025 molarity. So what you need to know is that you can find the H+ concentration using this information. That's because HCl ionizes in water to give H+ ion and Cl- ion. And you need to look at the ratio, molar ratio, to figure out H+ concentration using HCl concentration. If you're given 0.025 molarity of that, given that the volume of this solution is the same, you have 1-to-1 ratio, you have 0.025 molarity of H+. So you can use that information to find your pH, because pH is negative log of H+ concentration, and we know that H+ concentration is 0.025, so all you have to do is H+ negative log of 0.025 molarity. But the second problem is slightly different. That's because we no longer have 1-to-1 ratio. If you write H2SO4 being ionized into the ions, you get 2 H+ and 1 sulfate. So now we have 1-to-2 ratio. So if you remember dimensional analysis, you can just set this up as if you have 0.025 mole of H2SO4, you actually can put that 1 mole of H2SO4 in the bottom, and you can put 2 moles of H+ ions on the top because it has 1-to-2 ratio, and these units will cancel out, and you can get the relationship that every 0.025 moles of H2SO4 that you have double that amount for the hydronium ion. So your pH now is going to be negative log of 2 times 0.025. To solve the third problem, which gives you the base instead of the acid, you need a relationship that the pH and pOH can be added together to give the value of 14. And that P just means you're taking negative log. So if you think of it that way, negative log of H+ concentration, if you add up with negative log of OH- concentration, you can actually get 14. Because they give you the they give you the molarity of the base, you can go ahead and find the pOH of that. And when you do that, you're just simply doing negative log of this value right here, right? So because NaOH splits into Na+ and OH-, because it has 1-to-1 ratio, if you have 0.025 molarity of this, you get 0.025 molarity of the hydroxide. So to find the pH, what you can do is you can take negative log of this value right here. That will give you pOH. And you can actually subtract this from 14. That would give you pH because they need to add up to 14. So you can do 14 minus this value should give you your pH value. So for the next problem, always remember the relationship. If you are not very familiar with the logarithm, you should now become familiar that pH is negative log of hydronium ion concentration. But when they are asking you to, when the problem is asking you to find the H+ concentration, you can rearrange the logarithm where it becomes H+ concentration equals 10 to the raised to the power of negative pH. So you can use this sort of relationship to answer something like number 4. I just want to go over number 7, discuss this a little bit. I should actually have given you that the K value for this is 1.8 times 10 to the negative 5th. This is very similar to the lab. In the lab, you learn that acetic acid goes through equilibrium process. So you can write this equation, CH3COOH partially ionizes through equilibrium to produce H plus and CH3COO minus. If you read the problem, initially you start off with 2.00 molarity and you have 0, 0 here. The change is that you have to take the reactant side and shift a little bit to the right side. It's impossible for you to go ahead and take from the product side and give to the reactant side, because then you will end up with negative concentration, which is impossible. So what you know is that you can subtract from this side and go ahead and give it to the other side. And when you make this change, it has to be according to the molar ratio. Everything is 1 to 1 to 1. So it's minus 1x, and then on this side it's plus x plus 2x. But if you run into a problem where you have a 2 here, you need to actually do plus 2x. So you need to make these changes according to the molar ratio. Equilibrium is established once you made this shift. So it's all you have to do is add initial plus the change. In this case, when you add these two rows, you get 2.00 minus x. And then you get x and x on the product side. So if you just take this and try to set up K, it is nothing more than H plus times CH3COO minus, which is an acetate ion, over the acetic acid. And you should remember all of these concentrations are not at equilibrium, not at the change, but you need to take the not at the initial, not at the change, but it has to be from the equilibrium concentration. So at equilibrium concentration, you have X for the H plus concentration, you have X for the acetate ion, and at equilibrium, acetic acid concentration is not 2, but it's 2.00 minus X. We already know that K value is 1.8 times 10 to the negative 5th. And you can go ahead and solve for X. And if you look carefully, our X is hydronium ion, which allows you to figure out the pH value, because pH now is negative log of X, because X is H plus. If you remember the lab, we actually had different unknown. In the lab, you actually measured this pH value, and therefore you were able to find the X by doing 10 to the negative of the pH value that you actually found. And you use that to figure out the K. But in this problem, we have different unknown. You were actually given K and you were trying to find the pH. So the way you set up the problem is exactly the same, but we just have a different unknown. So I really want you to think about that.